Could you maybe describe the field of astrophysics as well as some of the questions that the field actually tries to or seeks to answer about the universe? Right? You sort of hit on the idea that physics is this sort of fundamental field that encompasses so many different areas within the natural world and within science. Right. But I would like to you, if you could, just delve into, the field of astrophysics and what it specializes in, what it seeks to answer.
Sure. It's actually a really interesting question, because if you'd asked that question maybe 30 years ago, the answer I would give would be quite different. Astrophysics has evolved a fair bit over the last few decades. So up to maybe 30 years ago, there was a really kind of fairly clean delineation between astrophysics and other branches of physics. Astrophysics was seen as the study of things in the universe, which in essence means everything outside of Earth's atmosphere. So astrophysics would be the study of anything that's not on Earth and is outside Earth's atmosphere. So it could be anything from, small asteroids orbiting near the Earth, that would be astrophysics, strictly speaking, all the way through to galaxies, which are trillions of times bigger than an asteroid and operate very differently. And so even back then, it was seen as a very broad field. And that's still the case. So astrophysics today does encompass all of those things. It can be anything from meteorites to other planets to stars to the stuff between stars, because space is very, very empty, but it's not completely empty. There is stuff between stars. And in astrophysics, we call that the interstellar medium, or, inter between stellar stars, medium, just material stuff, and there's hardly any of that, it's a couple of atoms per cubic meter. It's really just not much there. But it turns out that interstellar medium is really, really important for understanding where galaxies come from. So we study it. But then it's also things like all the different kinds of stars you can have. There's a whole plethora of different star types, and understanding all of those and where they come from is part of astrophysics. Then there's understanding just why you have galaxies, and that in and of itself is kind of an interesting question, because you might think, well, why should stars kind of tend to clump together into galaxies? Why don't they just sort of spread throughout the universe kind of fairly evenly? And it turns out that galaxies exist for a variety of deeper reasons, which we're still trying to understand. Then there's black holes, which are a whole ballgame in and of themselves. They're extremely mysterious objects. We still don't really have a good idea of what they are. And so a lot of astrophysics is spent trying to understand what those are. And then there is, this is going to sound a bit grandiose, but it's nonetheless true. Astrophysics also seeks to try and understand why the universe itself came to be. Why do we have a universe to begin with? We've got all these galaxies, all these stars, all these planets, and you can just pose the most basic sounding question, which is, well, why does that exist? How does it exist? How did all of this happen? What's the storyline of creation? And astrophysics tries to answer that. We've come a long way, but there's still a lot to do. The change that I think, at least that I've witnessed over the last few decades, is that astrophysics has stopped being as separate a subject from other fields of science as it once was. So, for example, nowadays the field of astrobiology is a big thing. There's a lot of universities that have departments that study astrobiology, which is anything from the survival of biological organisms from Earth in space, which is a critical thing, because if we want to send human beings to Mars, you have to deal with a whole set of challenges that you don't have to deal with if you just want to send humans to the moon. So, and the reason there is that you have to go a lot further. You have to deal with much higher radiation levels, and so there's extra challenges. But there's also the field of astrobiology has really blossomed, because I think that in many ways we've realized that understanding the origin of life on Earth involves just understanding the origin of life in general, and how you can create really basic biological organisms that exist in quite harsh environments. And then, you know, it sounds like it sounds weird, but there's also the realization that, hey, maybe there is other life out there. You know, it sounds like I'm just saying, hey, aliens, but it's a serious question. Like, how likely is it that there's life out there? And so astrobiology tries to answer that by saying, well, how likely is it, and what sort of life might evolve? That field really didn't exist 30 years ago, but now it's a big thing. Another area which has really blossomed recently is a field called particle astrophysics. So scientists have realized that the stuff that's done in those big particle accelerators, like at, say, Fermilab or CERN or the relativistic heavy ion collider, it used to be the case that scientists who studied particles would go to their particle accelerators and bang particles into other particles and see what happens. And astronomers would go look through their telescopes and see what they saw. And the two groups wouldn't talk to each other because they thought, we've got nothing to do with each other, you know. But in the last few decades, it started to become apparent that those two groups had to talk to each other, because the things that you can understand about the fundamental laws of nature from particle physics inform you about the universe. And at the same time, what you can see about the universe tells you things about the fundamental laws of nature that are very difficult to understand in a particle accelerator. And so the last 10 or 20 years especially, particle physicists and astrophysicists have really started to talk to each other, have joint conferences, have joint journals, and really started to say, hey, look, we can really help each other. And so overall, I would say astrophysics has become a very broad discipline, where the idea that you've got the whole universe as a stage for your experiments, you know, you can look at things, you can do the most grand experiments of all. The realization that those experiments can really help in so many areas, from the origin of life to the origin of the universe and everything kind of in between, I think has started to happen. And so astrophysics is this kind of, it's a broad thing these days.
Thank you.